All right, so in this video, I wanted to go over the stuff we already talked about previously. Now, I wrote these out ahead of time, so if you need to, you can go and pause the video so you can write them down. But let's kind of go through. So we're talking about exponential functions. We know the general structure is the f of x equals a times b power of x. And like the key thing here is making sure you realize that the variable is in the exponent position. That's the key difference here. That's the new part. Okay. And the things we know we've done so far, we know it's a curve, right? So now I'm talking about that first bullet point. We know it's a curve, right? We know it starts very, very close to that x-axis, but it doesn't actually cross it. And then depending on the question, it either grows or decreases very, very fast. It grows or it shrinks, right? It kind of shoots up or it shoots down. And then we also went over the idea of you can use a function table to figure out exact points so you know exactly what this is going to look like, right? We have a general idea, we know it's a curve, but to get exact points, you could use a function table. And then we also looked at the function tables in general, and if you need to, go back and review videos 1 and 2 from this unit, and make sure you're comfortable with those exponent properties, okay? Because you do have to be kind of comfortable with those to be able to figure out the function table part. Okay, that's essentially what we've gone over so far. Now what I want to do next is I want to go through one question completely. So like make a function table for it and draw the graph that goes with it. Okay, so we go ahead and scroll down. And this is the kind of thing that you would see on like a quiz or a test, right? One question from beginning to end. Okay, so let's say the question is complete a function table and graph. And let's say our equation is y is equal to -3 times 1/2 to the power of x. Okay, so again, we know what it's going to look like, but we want to get the exact points. So we can go ahead and make a table. And again, technically, you could plug in whatever points you want, but we want to get a good idea of what the thing's going to look like. So that's why I always go with the default of like -2, -1, 0, 1, and 2. That'll give you a decent idea of what the thing's going to look like. Okay? And then yes, you do need to show your work on these. You can't just give answers and get credit for it. Okay, so you need to show your work. So show that you are plugging in the -2 part. Okay, so let's do that. So plugging in -2 for x, here's what it looks like. -3 times 1/2, and now x is -2. So here's where those exponent properties come in, right? You have to remember that the way you would deal with a negative exponent is by that number changing sides. So 1/2 is going to flip around and become 2. And once it changes sides, it becomes a positive exponent. Now, if that was already a 2, then it would switch around and become 1/2. It just changes sides. That's how you deal with a negative exponent. And then from here, you can do it relatively easier, right? You can do some exponents first. 2 squared gives you 4. And then -3 times 4 gives you -12. So we can plug that in there. Okay? And then repeat the process. Plug in -1. So -3 times 1/2, power of -1. Again, we have a negative exponent, so it's going to cause that 1/2 to flip upside down and become 2. Now it's a positive 1. Okay, anything with positive 1 power is easy. It just doesn't change. So it's just saying what's -3 times 2, oops, which is just -6. Okay, and again, you will see a pattern. Well, there is a pattern. Hopefully you see it. But you can't really get it from just 2 points. So you need a third one to kind of test it out. The 0 is probably the easiest one of all of these. Okay, so let's go and plug that in. So -3 times 1/2 power of 0. The reason why the 0 is the easiest, because if you remember, anything to the power of 0 is 1. So we're left with this. That negative 3 is still there, but now we're just timesing it by 1, which negative 3 times 1 is just negative 3. Okay? So now hopefully you're starting to see some patterns. But if you don't see the pattern, just keep going, right? So plug in 1. So negative 3 times 1/2 power of 1. Okay, and then the first power is itself, so it's negative 3 times 1/2. Okay, and you can just multiply straight across and get negative 3 over 2, which is the same thing if you wanted to change it to a decimal. It'd be negative 1.5. Okay, so put that over here. So negative 3 over 2 or negative 1.5. And then the last one, plug in 2. Negative 3, 1/2, and plug in plug in 2. And then 1/2 squared, well, that's 1/2 times 1/2, which is just 1/4. And then multiply those across, again, negative 3/4. Which again, you could use a calculator to plug in and get a decimal. Okay, let's write that over here. Now, I've been saying that there's a pattern, and some of you guys have caught on to this pattern, being that the pattern has something to do with the equation, right? So looking at our function table, going from one step to the next one, the part that's actually happening is decreasing, right? So we know it's either subtraction or division. And the reason why you need at least 3 is because you need to test a point out, right? If you look at just the first two, the negative 12 to the negative 6, that could be adding 6 or it could be like dividing, right? That's why you have to check the next one, because we're going to get from 6 to 3, it is division, right? So we're actually dividing by 2 each time. That's why going from negative 3 to the next one, it's negative 3 over 2. We divided it by 2. And then going to the next one, negative 3 over 4. We just keep dividing by 2. Now, some people have realized that it's not a coincidence that the B component is 1/2. So that actually kind of tells you what the pattern is going to be, which is kind of nice. Okay, so keep that in mind in future reference. Now that we have our table set up, now we can draw our graph and see what this thing's going to look like. We have an idea. We know it's gonna shoot up or shoot down, but let's get an exact graph going. Okay, I'm gonna scroll down a little bit so you can still see the table, and let's draw a graph. Remember, usually 5 by 5 is a good starting point. If you're using line paper, again, make sure you're putting these tick marks in. Especially if this is a quiz or a test, if I can't read your graph, then I can't grade it. Okay, so make sure you guys are making it as neat as possible. Okay, and then we just go and graph the points. First one, -2, negative 12. Now that one's not going to be anywhere near on our graph, right? Negative 12 is like way at the bottom, so we're not going to worry about it. Okay, the rest should be good enough to give us the pattern. Okay, so next one, -1, -6. A little bit off the graph, but not too bad. So that's left 1, down 6. And I actually did 6 tick marks, so it fits on my graph. Next one, 0, -3. So 0, down 3, which this is actually another one I wanted to point out. Is it a coincidence? I'm going to scroll back up for a second. Is it a coincidence that whenever you plug in 0, you end up with whatever the A component is? I'll let you guys think about that. All right, let me scroll back down. So 0, -3 is the blue one. Okay, let's go ahead and do the next one. We change colors. Okay, so 1 comma -1.5. So right one, down 1.5. About there. All right, we're starting to see the general structure, which is good. Okay, and then we need one more. So let me change the color again. 2 comma -0.75. That's right 2, down so a little bit right there. Okay, so now we can see the shape of this graph. Remember, it starts off very, very close to that x-axis. So it starts very, very close to that axis. And then based off our points, it's shooting down, right? So we're going to start very, very close to that x-axis, connect these points, curve, and then almost vertically down. And then there's our graph, okay? Now in the next video, we're going to go over like how can you like tell what this is going to look like just by looking at the equation. Okay, we kind of hinted at some of the components in today's video, but that's what the next video is based off of.